Hello friends, welcome to Triple tutorial channel. In this video we are going to discuss about EMF equation, turns ratio, transformation ratio and related numerical problems with these points. We know that already we discussed about the working principle, constructional details and the idea about ideal transformers in the previous video. Okay. So let us discuss about these points in this video. First, let us discuss about EMF equation of transformer. We know that transformers are works on the basis of Faraday's laws of electromagnetic induction, that is mutual induction here. A transformer must have two windings, primary and secondary windings. When we give supply to the primary side of the transformer, then EMF will induce in the secondary side, that is mutual induction. Okay. That means a transformer is electrically separated but magnetically coupled through a low reluctance medium, that is core. So let us discuss about the EMF equation of transformer. Consider a transformer having primary number of turns N1 and secondary number of turns N2. E1 will be the EMF induced in the primary side and E2 will be the EMF induced in the secondary side. And let us consider some more terms. Phi m. Phi m is nothing but the maximum flux density, and which will be equal to phi m is the maximum flux, which will be equal to Bm into A. Bm is nothing but magnetic flux density. So the product of magnetic flux density and the area of cross section of the core will give you maximum flux phi m. So the unit of the flux phi m will be in Weber, and F will be the frequency of the supply which is given to the primary side of the transformer. Okay, these are the main parameters that we need to find out the EMF equation of the transformer. Okay, N1, N2, E1, E2, phi m and F. Consider this diagram. Phi m, or the flux, will be maximum at the 1/4th time period. Here we are considering a complete cycle. For a complete cycle there will be two half cycles, and the 1/4th of the time period, during the at that point flux will be maximum. That means in terms of frequency, 1/4 into F will be the time period. Okay, so that let us see the average rate of change of flux or average EMF per turn will be d phi by dt. So here dt, or the time, will be 1/4 of in terms of frequency. So that the average EMF per turn will be 4 phi m F, that much of volt, or that much of Weber per second. Then the RMS value of the induced EMF per turn will be 4 F phi m into 1.11. 1.11 is nothing but the form factor. If we multiply form factor with this average EMF per turn, then we will get the RMS value of the induced EMF per turn. Okay, so that finally E will be 4.44 phi mF. Here phi m can be Bm into A. Bm is nothing but the flux density, maximum flux density. So if we consider the number of turns in the primary and secondary, that is N1 and N2, then we will get the EMF induced in the primary side will be E1 will be equal to N1 into 4.44 phi m into F, and E2 will be equal to N2 into 4.44 F into phi m. Here phi m is considered as Bm into A. Okay, this is the EMF equation for a transformer. in terms of its primary and secondary sides, it will be E1 and E2. Okay. So now let us see the turns ratio of transformer. Turns ratio of transformer is nothing but the ratio of EMF induced in the primary to the secondary side, or it will be the ratio of number of turns in the primary to the number of turns in the secondary. So turns ratio will be equal to E1 by E2, which will be equal to N2 by N2, that will be equal to 1 by K. Here K is nothing but the transformation ratio. So now let us see what is meant by transformation ratio. Transformation ratio K is nothing but the ratio of EMF induced in the secondary to the EMF induced in the primary, or simply N2 divided by N1 or V2 divided by V1. So from these two equations we can simply see that transformation ratio and turns ratio are just reciprocal. Okay. E2 by E1 will be K and E1 by E2 will be 1 by K. Okay. And based on this transformation ratio concept, we can see that if the voltage across the secondary is higher than voltage across the primary, or simply if N2 is greater than N1, then the value of K will be greater than 1. That means the transformer will be step up transformer. Otherwise the transformer will be step down transformer. Otherwise means if V1 is greater than V2 or N1 is greater than N1, then the value of K will be less than 1. That means the transformer will be step down transformer. So based on the value of this K, we can define, or we can find out if the transformer is, whether the transformer is step up or step down. So based on this, we can calculate, or we can solve a problem. So a single phase transformer has 400 primary and 1000 secondary turns. The net cross-sectional area is 60 centimeter square. If the primary winding be connected to 50 Hz supply at 520 volt, then calculate A. Peak value of flux density in the core. B. Voltage induced in the secondary winding. Okay. Here some data are given here. 400,000. These are the number of turns. So number of turns in the primary will be N1 will be 400, N2 will be 1000. Cross-sectional area will be 60 centimeter square. The frequency is 50 Hz. V1 is 520. Okay. So based on these parameters given, we can calculate. First we can calculate flux density in the core. For that we can first write the EMF equation of the transformer, that is E1 is equal to 4.44 F N1 into phi m. Here phi m is Bm into A, so that we need to find the flux density Bm. So Bm is equal to E1 divided by 4.44 F N1 into A. So the whole data are given in this problem, so that E1 is 520 divided by 4.44. F is frequency is given here as 50 Hz. N1 is the number of turns in the primary, that is 400, and the area is 60 into 10 raised to minus 4, that much of. These are the values to find out the flux density. So after calculating, we will get the flux density as 0.976 Weber per meter square. So next we need to find out the voltage induced in the secondary winding. That is voltage induced in the secondary winding, that is E2. We know that E2 by E1 is equal to 2.5. 2.5 is nothing but transformation ratio. From these details data is given, that is based on the number of turns in the primary and secondary, we will get the transformation ratio as 2.5. That is N2 by N1 is equal to E2 by E1 is equal to 2.5. so that from here we will get E2 as 1300 volt. So these type of simple questions that we can accept for technical exams. So hope you like this video. Thank you.